Welcome to yet another webinar in the Iliad webinar series. I'm Bente Lilja. I'm going to be your host and introduce to you also the topic of the day. Today we are going to talk about data lakes and data spaces and how we can collectively as a community move towards best practices. We have a fabulous panel of experts sharing their knowledge and experience with the data lakes and data spaces, even though it's rather a new concept, but this is what we are going to discuss today. So first of all, some house rules. We are going to have a dialogue. So we have a series of short presentations first. During these presentations, we are also publishing some very simple polls to keep you on the toes, to share with you, to share among ourselves where we come from, some information, etc. So, and also inspiring the dialogue that we will have at the end, after all the presentations has been done. Some quick questions for clarification during or in between the presentations we might be able to do. But overall, we want you to engage with us and each other in creating these best practices and sharing your knowledge about data lakes and data spaces. Use the chat very vividly and actively. You can comment, you can ask questions, share information. We want you to engage and to create this community. So please use the chat. Keep muted while you are not speaking, but then we will give the floor to as many of you as possible in the discussion part. That's what we aim for. Anyways, I will start now with sharing the program to remind us all about what is the program of today. Here is the agenda. We will start with a bit of an introduction to Iliad, for those of you who are not familiar with that, and also how we are integrating the best practices perspective here. Then Arne Jørgen will introduce us to the concept of data spaces and data lakes, specifically in the Iliad Digital Twins of the ocean. Then we will look at data lakes and data spaces seen from Destination Earth with Thomas. We have also some implementations experiences or about to get towards data space support for digital twins with data lakes from Tom. And we will generally speak about the Green Deal data spaces, and Joan will give us a very nice overview of that. And we also have the great project who recently showed us some the results and engaged with the stakeholders, and have also later a follow-up meeting on data spaces in the Green Deal, marrying complex technology with robust governance, promotion, circulation by Mark, and all of you in the discussion part. So I will skip this introduction part, except to saying that I am an innovation manager in Iliad. I work with data management and data policy, open knowledge, specifically engaged in GEO, the Group on Earth Observation, and I have been applied use of data in many different contexts. So here now we are talking about digital twins. So Iliad is digital twins of the ocean. We have multiple twins. You will learn more about that. And it's simply a virtual environment representing the ocean, capable of running complex predictive management scenarios and having the freshest, the latest information that is relevant for your specific case. And it's an innovative system that integrates across many disciplines, sensors, models, and digital infrastructures. And we have focused on making all of this interoperable. Is necessary to make it interoperable in a cost-effective digital twins of the ocean in this case. Our approach is to acknowledge that the ocean is vast, it's obvious, and complex. And it consists of many different components, so geophysical, biological, and numerous interactions between them, and also the human activity. This complexity is reflected in the European digital twin of the ocean, and EU, the European Union, is investing enormous amounts in developing this European digital twin, which consists of complexity or multiple resources invested earlier, before Iliad and before other initiatives, and also we have several investments at the same time, and that's why part of why we are here. So it's an ecosystem of these twins and the components that comprises this European digital twin of the ocean. We base what we do on aligning, or well, we focus on aligning the different technologies and event and components of the ecosystem by using similar standards, APIs, and best practices. So Iliad in a seashell, you see this, we are enabling an ecosystem of interoperable digital twins, connecting existing resources, adding new resources, including citizen science. We want to make this available on a marketplace. Actually, we have a first version of the marketplace already, where all of these twins can be accessible, findable, and accessible, but also the different components of it, so that we can build new twins addressing the specific challenges that we see in society. And of course, what we are doing while developing this is actually also providing solutions to some of the challenges that we are facing related to the ocean. As I said, we are developing multiple twins. We are talking about multiple twins. And in Iliad, we sort of divide them in thematic twins and also differently located twins, because it matters where you are located. If you are in the Arctic or if you are in the Mediterranean, it's a different story. It's similar, but different. So you see here that there's a vast area. There are many areas, thematic areas that we address, and some of them can be combined. And this is, reusability of the technology that we develop is important. Here you see the logical architecture. I show it, and Arne Jørgen, he will go deeper into it. But you see it consists of different components. And what I wanted you to notice here, that integral in our logical architecture in Iliad, you find the digital twin of the ocean, best practices, methods, and standards. And this is where the data lakes and the data spaces fit into our work. And we say that the digital twins are actually a very good laboratory, say, to combine the data lakes and data spaces. And this is what we are going to discuss today. Collecting these best practices, we have a home for that, the oceanbestpractices.org. This is Jay Perman, several of you know him probably. That is facilitating both a place where you easily can submit your best practice, where you can find it. There's a repository for it, and they are developing also a better interface for the users to find it. So this will be what we want you to think about when we are talking about data lakes and data spaces specifically related to twins today, is to discuss how we can start this process of developing common data best practices for us. So I will skip that. Just a quick word also that Iliad is a EU-funded project. We are 56 partners. We are not covering only Europe, but we are also have partners in Africa and the Middle East. It's an innovation action, and you see it's a rather big investment, or close to 19 million euros in total from the European Union and the partners. Yeah, this is, I will stop. This is from the old. I will now introduce you, Arne Jørgen. You are going to define for us the concept of data lakes and data concepts, data spaces, And Arne Jørgen is our scientific manager in Iliad, and he is an experienced digital expert working for SINTEF Digital. Arne Jørgen, the floor is yours.
Thank you, Bente. You hear me okay and see the screen?
Yes.
So this is on data spaces and data lakes from a definition point of view as a basis for the further discussion, also in a digital twin context. And for that, I'm using one of the latest reference architectures from Destination Earth, where you see the placement of both data spaces, data lake, and also digital twins. So the core elements for those that are familiar with Destination Earth are basically the core service platform for the entry point for the users, the data lake, where the data that is going to be used close to the processing part of the digital twins is gathered and made available in a kind of context optimal for processing. There is a number of digital twins, and we'll hear more about this. But we also see that the data spaces that has been added fairly recently are connection points into the data lake, providing sources of data. And we have, as you might know, an increasing number of common European data spaces. This is one of the later figures that shows 14 of these. In the Green Deal context, which Iliad is a project under the umbrella of course, the Green Deal data space is relevant. We have inherited some aspects for semantics information models from the agriculture data space activities. And also EOSC, the European Open Science Cloud, has also now been promoted as a data space. So these are our typical data spaces that we will come back to. And you see some of them here on the data spaces also surrounding the data lake of Destination Earth. So from a definition point of view, it's good to go to ISO and definitions exist. And indeed for digital twin, it does exist in ISO 30173. A digital twin is a digital representation of a target entity, typically somewhere in the real world. It can be virtual also, with data connections that enable convergence between the physical and digital states at an appropriate rate of synchronization. And depending on the domain, the rate of synchronization can be in minutes or seconds, milliseconds, or months, or even years. And it's synchronization two ways, and it's also in time as well as in space. So we are in this context talking about environmental digital twins and digital twins of the ocean in particular, which is of course where the target entity is related to environmental area or the ocean. We saw the data lake in the middle. And for those that have followed, say, the evolution of the concept of data lakes, might know this as the place where raw data is stored. It has lately evolved into different types or levels of data lakes, typically bronze, silver, and gold data lakes. So bronze is where we have the raw data. The silver is where data has been curated and somewhat harmonized. And the gold is where the data has become analysis ready and perhaps cloud optimized, combining the various data types that are relevant. And here referring to the Big Data Value Association, 6 data types: the structured, time series, IoT data, geospatial data, media data such as image, voice, audio, text, and language, including DNA representation, cDNA, and graph structures. It's relevant in this evolution to also compare this with the concept of data lakehouse, which is also an evolution with this medallion sequence from bronze, silver, gold. I'll shortly show that. And then we have the data spaces. And again, the word kind of means what you decided to be. So we have to go into the definition that we mean in Europe with the European common data spaces. This is the context when we talk about data spaces here in the European community projects. And this has to be defined to be a decentralized, governed, and standard-based structure to enable trustworthy data sharing between the data space participants on a voluntary basis. We can look at the Data Spaces Support Center.eu project and website to find further details on that. And it's related then to a market of data sharing. This can be compared with data mesh that has a number of relationships similar to data lake host has to a data lake. So I'll come back to that shortly. And finally, we have some representatives of the Green Deal data space activities in Europe, which is then such a data space, but in particular with environmental and Green Deal relevant data, including high priority data sets. And we will come back to this. So these are the official definitions. And as things are a bit say evolving in details, it's good to maybe point out that data space as defined here in Europe has interesting relationship to the concept of data mesh that has been used internationally, originating a bit from US. It's the commonalities is that we are talking about data sharing and data reuse, both within and between organizations. The data space focus in particular on data reuse across organizations, while the data mesh principle is typically used in larger organizations between different departments having responsibility for their own data. I will not go into the total details of these definitions, but just pointing out this relationship. In the same way, also pointing out the link between data lake and the data lake house from this medallion architecture I just mentioned. That the evolution of data lakes has been to look at data in these three levels. The classical data lake of raw data for the bronze level, the validated curated data on the silver level, and then evolving to gold data, which has been enriched and made analysis ready and typically also cloud optimized. So when we talk about data lake in the digital twin architectures, often the gold data lake of ARCO, analysis ready and cloud optimized, and data might come then from data spaces or from other your own data sources or other sources that are not necessarily using data space principles to be entering into the data lake. We have some examples of that, and in particularly, since we are talking about Iliad, which is one of the digital twins of the ocean projects, here is Edito, which is the European digital twin of the ocean. It's another project, procurement, Edita Infra, and Edito Model Lab. And this has been directly related to the destination Earth architecture with the Edito Data Lake and the Edito Engine. And there is a lot of sources of data going into the data lake, some with, say, direct bilateral agreements. And that's typically what Dito is working on now with IMODNet and Copernicus Marine Services, CMEMS. But one could foresee, even though it hasn't been highlighted, that data spaces can be part of this environment of providing data that can go into the data lake. Then this is being supported by a digital twin engine to do the processing of models and data integration and fusion and prediction and analytics for all of these different pilot areas, typically added also with additional data such as biodiversity data, marine species, socioecology data, and there are actually different projects that are addressing in particular this area. One of these is the DTO Bioflow project. So this is, I'll move to that. Here we see a picture to the left of the Dito Infra architecture and stack, and the point is to highlight now the data lake here in orange in the middle, which is providing the data for the digital twin engine and interacting with the services and the user interfaces. And the data lake here is a gold lake that is analysis ready and cloud optimized, using typically Apache OpenStack Kubernetes architecture. A storage that is in an S3 say interoperable bucket with Minio. And the representation technologies here is Stack, Spatial Temporal Asset Catalog, and file representation such as SAR, GeoSAR, also Parquet and others that are optimized a bit for analysis. So this is kind of the digital twin part of it, but we see to the right here the digital twin of the Ocean Bioflow project that started some months ago, is focusing on biodiversity data and observations. All kind of observations from imagery to acoustics to specimens to citizen science is then being collected from all of these sources, partially fueled through IMODNet biology or through other direct sources, being compliant with the ontologies and vocabularies of GBIF, the Global Biodiversity Information Facility, and also other sources. So there are different already existing aggregators here that might not be following all of the principles of a data space, but can eventually play under some of those rules. So the idea is to be able to reuse some of what we have and to elaborate further on this data space trusted data provider aggregators to the right. In the Iliad project, we try to address this from this perspective. So this is a digital twin pipeline from digital twin data acquisition, the twin representations, the analytics and predicting models, and the visualization and control. So this is the previous picture was read from the right to the left. This is from left to the right. So the observations and the data is coming in from the left. We have a number of sensor data and handling real-time sensor data with stream handling. But we also collect existing data from CMEMS and from IMODNet, also CDataNet, also EOSC, the European Open Science Cloud, and CMEMS in the context of being viewed as a data space and see how that might, say, follow some of the data space principles, and in particular the Green Deal data space that we'll hear more about. In addition, we have citizen science data, biodiversity data from the DTO Bioflow and other sources as we just saw, and also socio-ecological data in actually 4 new projects that will start in the summer that is about bringing socio-ecological data into the digital twin ocean. And that means that it goes into the data lake. And if everything is on the same, say, physical location, typically with one of the European supercomputers, it will go in the same data lake to be close to processing. But since we have a number of twins, they don't need to run in the same physical place, all of them. So there might be multiple data lakes, and there is a question, what is the right ARCO analysis ready cloud optimized representation form? Different twins might need different representations, but the preferred current focus is, as I said, on STAC, the spatial temporal asset catalog. Did we lose? I didn't see my slide. I had to go back. Something happened with that. Here, I'll put it up again and show it here again. Okay, now you see it back. So the data lake is where the data has been then extracted from a lot of sources. So, I mean, we talk about multi-petabytes of data here, and what you need for a particular twin is a subset of that. So we need this extraction and the semantic interoperability harmonization technologies that will help to do the extraction, which will also help with the semantic interoperability using information models and ontology mappings. And will also be support here for the catalogs and for the interactions. And this year is where we see some European data space technologies emerging, the simple procurement project from Digital Europe, the IDSA, the International Data Spaces from Gaia-X, and also IODIS, Ocean Data Information System, provide a meta catalog, are all sources here to help the interaction with these various data spaces. And then we will have the engine that will be able to execute the models with the data, supported with AI and machine learning, and choreographed or made connected through workflow with different workflow engine, Iliad using the common workflow language. So there are others, Destination Earth and Edito is currently using AutoSubmit, which is similar but slightly different. Various visualizations and control and interactions, which can be more than one view, of course, on the same model, and the access to AI and machine learning services, as well as to the more broader platform service environment that we have both in Destination Earth, Dito, and in Iliad. In Iliad, we are also making models available in the marketplace, as well as twins and pipelines. So not only, say, a data space, but a model and a twin space, which we believe is also very valuable to be able to efficiently build the new digital twins in the future, according to the best practices, methods, and standards. So that's the introduction to the terms and the context. And then we go over to the next presenter.
Yes, thank you very much, Arne Jørgen. While you were speaking, maybe I posted the poll a little bit early, but anyways, I ask you if you understand now the difference between data lakes and data spaces. Just I will share with you the poll result. Not all of you have, maybe we should ask it again towards the end. Of the webinar, but just a quick poll now shows that 66% of you do understand, some, a very few no, and still some that are not sure. So we will, I hope that this will, after, at the end of this webinar, this will be much clearer when we have discussed together. So thank you for participating in the poll. Now, then we are moving on to the next presenter, which will be then you, Thomas. Are you ready to share your perspective from Destination Earth? So, yeah, while you are looking at that, so Thomas is a technology partnership lead of the Destination Earth Technology Partnership. The Destination Earth. He works at the the European Center for Medium Range Weather Forecast, and he is focused on ensuring that the technologies required for the Destination Earth aligns with the Europe's and national digital strategies, both ECMWF and also member state capabilities. So, Thomas, the floor is yours.
Thank you, Bente. I hope you can see my screen.
Yes.
Yeah. All right. Perfect. So I will share a couple of slides on Destination Earth and how it links to data lakes and data spaces. So without further ado, first, quickly, Destination Earth. I think by now it should be known to a lot of people, or I guess, but Destination Earth is a flagship initiative directly funded by the European Commission to develop a highly accurate digital model of the Earth, a digital twin of the Earth system, and delivers bespoke simulation capabilities to be able to model, monitor, and simulate natural phenomena. And the aim of Destination Earth is to turn it into actionable adaptation strategies and mitigation measures. So it's indeed a digital twin that allows you to interact with a digital replica of the Earth, while at the same time it feeds off observational data of the same system. So obviously we need a lot of compute power for that, and we're using EuroHPC resources for that one. And at the same time, we're also focusing more and more on AI and machine learning for the development of the models underlying the digital twin, and incorporating and involving a lot of European research and computational science groups. It's implemented by three so-called entrusted entities. That's us, ECMWF, European Center for Medium Range Weather Forecast, ESA, and EUMETSAT. And for this particular presentation, I got a few slides from EUMETSAT, who are responsible for the implementation of the data lake of Destination Earth. And I also have a few slides from the Commission to explain how Destination Earth links to the data spaces and also simple. So here's a very broad, sort of very high-level overview of the Destination Earth system and the responsibilities of the different entities. As you can see on the right-hand side, we have the entry point for Destination Earth, what we call the core platform, where users log into the system, interact with the system, can discover services, can discover data, and can ask policy questions, right? In the middle, you have the data lake, where on the one hand, the digital twin output data will be stored, but will also be sort of a hinge or a connection point with existing data holdings, using a federation concept where existing data will be made available through this data lake to destination Earth. And it will also be the link to other data spaces, and also the place where the simple components will be deployed to make that happen. And on the left-hand side, you see the role of ECMWF. So we are responsible for developing the first two digital twins, the one on climate change adaptation and the one on extreme weather events. But we're also responsible for development of the digital twin engine, which are the software components for data handling and interactivity with these digital twins running on the EuroHPC systems. So if we zoom in a little bit deeper, then here you have a typical example of the data flow through such a destination Earth system. Where in the middle part you see the EuroHPC system, where observational data will be used to feed into the digital twins, that then in turn produce quite large volume of data. In this case, we anticipate to be producing on the order of a petabyte a day for these particular digital twins. So you can imagine that in the future, when we potentially go to more digital twins running on this platform, the data rate, the production rate will be even higher. We're using a streaming concept on the EuroHPC systems to capture that data and partially write it to disk to store that temporarily for analysis. And then some of the data will be fed to what we call a data warehouse, which is basically part of the distributed data lake that's co-located with the EuroHPC system. So there a significant amount of the data that is being produced, but not all of it will be stored. We're thinking about roughly 30 petabyte or so of data that will be available there, but you can already see that with a production rate of 1 petabyte a day, that you cannot store all of that output data for a very long time. So we have to be quite selective. And then the additional data flow towards the service platform where the users are will be even a subset of the data warehouse. Will be only that data that is needed for a specific analysis. So we also will provide tools that can very precisely grab data from the data warehouse. For instance, give me the 2-meter temperature over Berlin, say, and then you can read on that specific data. So moving to the slides from Humansat on the data lake, here you can see this concept displayed very nicely. So on the left-hand side, you see the data spaces where we anticipate to have a federation of those data holdings. And on the right-hand side, you see the digital twins that are producing data and are storing that in the data warehouse. And on top, you see an additional bucket for basically user data. So if you have a specific data set that you want to use to execute your digital twin, or you want to combine specific data with the output of a digital twin, then this is the place where you can bring that data. Zooming in a little bit more, so this is the same picture, but then with a little bit more detail there. So the way these data lakes are being positioned are as a self-standing component of the destination Earth landscape. So it very much leans on the concept of geographically distributed physical elements. So as I mentioned before, you will have these data bridges that are co-located with the EuroHPC sites, and then you have a central data lake, which is more focused on the federation of existing data holdings and linking those data holdings to the destination Earth data lake and making that data available inside destination Earth, but also making destination Earth data available to other data spaces at some point. The technology that they have in mind for this particular component is a harmonized data access layer, which gives us sort of a generic view and a generic API towards these existing data holdings. So we're not going to convert data in a destination Earth format and store it in a data lake, but we will make the data available in its original form, but just provide an API that allows you to sample the data or to access the data in a generic way. And of course, it will also hold the digital twin data, so the extreme weather and the climate change adaptation digital twin data that's being stored in the data warehouse will also be made available to its native API for the digital twin API, but also to this harmonized data access layer. And on the data lake, there will also be big data processing functionalities to operate on that data close to where the data is generated to prevent moving data between the data lake and the core search platform all the time. Our last slides are from the Commission to explain the data spaces again, as was done also in the previous presentation. So again, here there's a clear understanding that we're talking about a federated data ecosystem, and that what links it together is our shared policies and rules, not a concept of replicating data or copying data around, but federating data and making it available. So that also means that data holders remain in control of who can access that data. So also all the policies around that data will be respected. So again, from a technical perspective, this is really about an integration concept where not all the data has to be in the same format, but you need the tools to be able to access that data, right? And then there's a simple component. Also there we see a clear role of simple inside destination Earth. It will be the smart middleware that is currently being procured that will enable basically also again a federation concept of the data between cloud and edge. And it will basically support all the major data initiatives that the Commission is funding, and that obviously also means destination Earth. It will provide an open source framework that also makes it easier to build your own component and customize it and tailor it for your own specific data space. And it covers a broad range of data spaces, right? The ones that were also listed on the previous slide, including destination Earth, and also a link to EOSC. And indeed, simple is a component that will interconnect and make these data spaces interoperable. So here's a last slide that I want to show, where basically you have a diagram of how that then would work in practice. So you have existing data spaces that have this simple component deployed in the form of an agent. Also, destination Earth will have such an agent that will link into the destination Earth middleware that will be deployed on the data lake. There in that particular box around destination Earth, you see that the simulation data is being provided towards destination Earth, but also the output of machine learning algorithms. And then we have also in destination Earth already a federation with existing data sources. So then you will have, I guess, several ways to get to the Copernicus data, which is a data space by itself as well. But here, Copernicus data will be made available inside destination Earth to use that, and also be made available through this simple agents towards the outside and link it to other data spaces. So yeah, that was in a nutshell destination Earth and how it links to data spaces and to simple. Thank you.
Thank you very much, Thomas. Very useful, and I want us all to remember the two last slides because I think that's the key discussion around best practices, how to actually use this technology. It lies there, and I hope that we can come back to that in the discussion part, and you will get some lights shed on this also from an implementation on HubOcean and a digital twin that Tom will speak about shortly. But before that, so thank you, Thomas. Before that, I will like to share the results of the poll, because I asked the audience while you were talking, Thomas, if they plan to use digital twins in the following areas of research and application. I mean, you showed that there are many different disciplines that you cover in Destination Earth, of course. So simply asking if there were plans within land, atmosphere, ocean, and none of the above, not sure. And you see, of course, since we are a digital twin of the ocean, most are related to the ocean here, but there are also land and atmosphere in the planning, and also not sure. So I guess it depends on what you are building that you you will maybe have a mix, or you're not quite sure what data or digital twin you will be using. So thank you again for participating in this. Paul, well, I didn't share the results, maybe. Yeah, anyways. Thank you, Thomas and Tom. We are moving on to you. You are going to, so you are going to talk about towards data space support for digital twins and data lakes.
Yes.
Tom, you are from HubOcean, and you are working on Iliad, representing HubOcean in Iliad. But more than that, you are also responsible for leading activities related to ocean restoration and governance. So the floor is yours.
Yeah, thanks, Bente. So I'm just trying to get rid of the picture so I can read my notes. There we go. So just a very quick introduction to HubOcean. So we're an independent non-profit foundation based in, well, just outside of Oslo, with a mission to unlock ocean data. We've got a particular focus on sharing industrial data because we recognize that this has a great potential, mainly due to the limited extent that vast amounts of industrial data can bring to the world. So that's why we're leading the Ocean Data Action Coalition of the High Level Panel. We're also a strong supporter of the Ocean Decade, and they're involved in a lot of data work there. So that's kind of a bit of background on the organization. We kind of see ourselves operating in the intersection between industry, governance, and science, and we're bringing this, developing this platform called the Ocean Data Platform, which is a data platform that aims to connect, aggregate, effectively in many different ways, bring together lots of different data for the ocean to drive solutions towards restoration and stopping the degradation of our ocean, and also advancing sustainable business, which of course those things go hand in hand. As Bente mentioned, we're part of the Iliad project. We're leading a task related to the data spaces and the digital twin engines, kind of having a bit more of an overview. So we've been working on the architecture and looking at how all of the different technical components can be put together. We're also, of course, bringing our platform into the project to understand how that can be used to support digital twins. And I use the term twins rather than a twin, which I'm glad that we've sort of got to that point now where we're using that definition, because I think, the future will be twins, and that's part of the talk that I want to give today on that architecture that you need to support that. And therefore, there's a big need on focusing on interoperability and understanding how all of these different components within the ocean data space connect to each other. We're fortunate in Iliad that we have a number of pilots who are very keen to sort of test out different technical components and make sure that they do figure out a way of everything working together. So I might come on to that a little bit towards the end. But I just wanted to and unfortunately there will be some duplication with what other people have said, and I think that's a little bit inevitable. But I'm maybe going to take things a little bit higher level because I'm not a technical person. So for me, it's kind of useful to set some definitions before I start talking into sort of more detailed things. And I'm going to talk around how we've been building the Ocean Data Platform. So first of all, wanted to talk about the sort of how I understand data lakes and why I think using the definition of bronze, silver, and gold is particularly useful. Because actually the way that we're building our data platform is that it has all of these components within it. And that's not to say that you always need to have bronze, silver, and gold in a data lake, but it just so happens that we do, because we have the ability to, bring in raw data, scientists going out on a cruise or streaming data directly into the platform. That would typically go into a sort of our Azure storage containers. It's all unstructured, but it's there for analysis. And because we're a cloud-based platform, of course, you're able to do the compute on that data. Either our data engineers or our users are able to work with data on the platform to sort of do some quality analysis, start to transform the data and harmonize it, and then that typically sort of move up into the silver level of a data lake. And then finally, you know, when data is well described with metadata, we have orchestrated data pipelines, and so that would typically be when it moves into the gold, and especially when it, you know, because we're an API first platform, that would be when it's in the gold, when it's in the data catalog. If people have the ability to find it, connect to it, filter it, search it, work with it, that's when it's in the gold. But I think it's really important for me that I started to understand these different definitions between different levels of data lakes, because I then think that helps build on that foundation to get towards what we mean by data spaces and building data lakes, data spaces, and the infrastructure to build digital twins of the ocean. So then sorry to go into kind of more detail, but I'll talk a bit about the why I have found this sort of concept of data mesh architecture particularly useful thinking about the ocean space. So I have much more experience in sort of understanding ocean science and than I do in these kind of technical things. But I think, you know, when you look at the architecture of a centralized architecture versus a federated or distributed architecture, it makes a lot more sense that for us, we apply these kind of data mesh type architectures because data is located in many different places. Of course, it can be connected and it can be brought into different things, like with the Ocean Data Platform. But it will always be that there is data in all different locations. And I think that then it's a mission that we should set ourselves to make sure that you can harmonize and bring that data together in one place. Also, the data mesh architecture has a strong focus on data as a product. You know, applying product thinking to data to make it more of a, you know, a star, not just something. I think that's where typically I sort of like misunderstood this, sort of originally misunderstood the data lake concept, is if you only think about the bronze and you think about this kind of like a place where you just dump data, that to me doesn't seem like a particular, it seems like a starting point, but it's not your end point. And so that's why I think the data mesh architecture is quite useful in thinking about data as a product. Also, the ability to sort of create self-service data platforms is really important for users to build their own digital twins. As I mentioned, the sort of ODP has that kind of like is cloud-based, so it has the compute there that's next to the storage. And design thinking is really important when you're building a platform like that. And kind of like all-encompassing these things is the federated governance of data. Again, when you have data that's in many different places, it's really important that you have good governance mechanisms and descriptions and data lineage, which is something that we're thinking about as we're sort of building our platform. So then this leads, by the way, this Carlos Grande that's linked below is where we've drawn a lot of inspiration from in building our platform. And I'd really recommend the blog that or his thesis that I've kind of linked to there if you wanted to find out more. I found it really useful, especially when building digital twins. You know, I think then you start to see like why this approach is a really useful approach, because it allows you to connect to data which is in different places, bring it into an analytical data plane where you can have raw data, you can have processed data, you can have live streaming data, and you can have computational analytics. And this goes back to a lot of the things that Arne presented originally. And you can have that all in an analytical data plane. Of course, the challenge with building a federated system is that these things may be in one place, but they may be in different places. So it may be that you have your bronze data lake somewhere, you have your gold data lake somewhere. How you connect those things is very important, and a lot of the work that we're doing within the Iliad project, and we have colleagues from OGC, for example, who are building APIs which are allow these kind of connections to take place. We have a lot of work within the Iliad project building federated catalogs, data semantic like metadata harmonization, like so. And this is like the ideal, not ideal. This is one way of doing data platforms and building digital twins. But of course, all of these components could be separated out into different places. And then just sort of wanted to finish then on why we're building the Ocean Data Platform in this way, and just to sort of show a little bit of the architecture of that. So we've kind of landed on building this platform for users, and effectively that could be used to build digital twins, but there are other use cases of it. And the features that we therefore sort of think around having are cloud-based data access, so that you can pull data through our APIs, and start to work with that data programmatically. Means that you don't have to download entire data sets anymore, that you just work with the data that you need, or the subset of data that you need. And of course, being API first means that you can do that in your own environment, or you can do it on our platform. We also have a bunch of unique data. That's one mentioned about unlocking industry data. That's kind of like one of our core tenets. But also the ability for users to publish their own data on a platform, we think is a very valuable thing to do, and probably at that kind of that's more thinking around like the gold level of data lakes. Publishing it somewhere where it can then be visible and used by other people is a really important feature. The benefit of being a cloud-based platform is that you can scale compute to your need. So you can have a very minimal environment, or you can scale it all the way up as much as you need, really. And we think that that's kind of useful feature for our users that we're thinking around. And also the sort of ability to have continuously updating data pipelines, so that when you access data through our catalogs, everything that you get is up to date. And we've sort of have feedback that that's a very important thing for people. Because we're currently in a closed beta state at the moment, we're working closely with partners, especially in the Iliad project, to understand user needs. I mean, we're a very sort of user needs driven organization, so it's great that the pilots that we have in the project are sort of actively testing, and that doesn't just go for the Ocean Data Platform. Of course, it's also for other technical components. Sorry, the poll and quiz has just jumped up. So that's kind of like, as we open up through 2024, a lot of the learnings that we get through working with users are going to be sort of featured in the platform. So I just wanted to sort of like finish on a few conclusions. I think it's one of the things that's helped me a lot is to try and be precise in understanding definitions, especially as a non-technically person. So this sort of definitions around like different levels of data lakes, and thinking around how that, I think that's really important. And I think the work on thinking about architectures and data mesh architectures is particularly useful, and also the sort of learning by doing. And I think that's how we're going to see interoperability between, for example, the Iliad project and Edito and many of the other sort of European and non-European. I mean, we're a global platform, so we are sort of also looking at how we work with initiatives in the US and around the world. So it's finding these opportunities to learn by doing it is really, really important. I'll finish there. Thank you.
Thank you very much, Tom. It's very interesting to see how you've been working on a concrete implementation, actually, of both data spaces and data lakes. I managed to publish the poll. If you haven't answered yes, please do before I end it. You have 1, 2, 3, 4, 10 seconds. So we asked you what, from your perspective, what are the key components? Now, Tom has mentioned several of them, of a data space to create digital twins of, so what are the key components to create digital twins of the ocean? And you got several options. API access seems to be the winner, along with continuously updated data sets. So, but there's also federated data catalogs, scalable computer, and then scalable computing power and collaborative data workspaces also seem to be of interest. So rather evenly distributed, I would say. So thank you for participating in this poll. This is useful for us, and I think I hope you see it useful for the entire community, because now we are collectively in this through many different initiatives and projects. Okay, so next coming up, And again, thank you for commenting and asking questions. We will come back to that after the next two presentations that will be on the Green Deal data spaces. First, Joan Maso, or data space, I think. So Joan Maso is one of our leading experts on data management, on standardization specifically, I would say. He is a principal investigator with CREAF and specifically addressing geospatial interoperability and GIS and remote sensing. And he has been involved in a high number of EU projects developing data sciences, understanding data science and implementations. So with that, Joan, I give you the floor.
Yes, thank you for inviting me. I will share my screen. That is the presentation that I would like to do today. And the title is very simple: Green Deal Data Space, the All Data for Green Deal Contribution. I'm Joan Maso, as it was said. This is the logo of my organization here in Barcelona with a tree. And let's go ahead and start. Yeah, I agree with one complaint in the chat that says that maybe these presentations are too abstract, and maybe we should show more detailed examples. I hope I can do that in my next presentation. For the moment, this is what I have for you. So I'm here to talk only about data spaces. Data spaces, we saw it's a contribution to actually the digital twins. One of the things that we can see in the definitions of the data space is that essentially this is about data transactions. This is not necessarily about data processing. So the way I see today, I believe data spaces has some capacities on data transformation, but not on data processing and on data modeling, because this is what the digital twin should be doing. So actually, data spaces are contributing to the creation of the digital twins, and this is related to the last question, my personal answer to the last question of Bente, the last poll. Also say there are many, 14, if I'm not mistaken, only those promoted by the European Commission. I'm interested in the Green Deal data space in particular. That's one cross-domain data space that should support the European Green Deal policies. That means climate change, circular economy, pollution, biodiversity, and deforestation. We are living kind of in a contradiction because we were so used to this open data, and now we are asked to also provide something for the digital economy. So I would like to focus my presentation on this kind of a contradiction. Public administration shall make public a set of high-value data sets or data sets in general. Those will use an open license. There is no need for authentication of users. Data can be redistributed freely. In the digital economy, the situation is different. Private companies can create new data sets or can transform data sets that can be high value or low value or whatever, but in any case, they are producing data for their own benefit. So possibly they want to share data just between other partners, but not in an open environment, maybe in exchange of other assets. So in the open data portals, data is kept by the producers. There is a catalog that collects the descriptions of the data. These descriptions show how to get the actual data. So there is some kind of a download service or data access API, and you get the whole data set or a fragment of it through a query. There is no concept of membership in data portals. While in data spaces, that's different. Users are known here because they should be trusted. So there is an authentication process. There is also a negotiation of a contract and accepting some kind of a conditions, maybe some kind of a money exchange through or to get assets. Only the authorized members can, of course, get the data. There is a track on the movements of the data, and those digital assets retain the access conditions so they cannot be redistributed with or to non-authorized partners or members of the data space. Well, fortunately, I have to say, we do not have to build the Green Deal data space at this stage. We are only doing research on the Green Deal data space, and we are focused on this idea of building blocks, how we could use the existing building blocks or produce new building blocks for that. So in this presentation, sorry about that, you will not see an architecture, but a set of building blocks that can contribute, for instance, to the fairness of the Green Deal data space, like metadata, data descriptions, metadata publication and discovering services, data exchange and encodings, data communication APIs for data cube sensor features, and elements to make things available, like identity management and access control and logs. About interoperability, we're talking here about data models and vocabularies and mappings, and something that in our project we call it the meaning service, where essential variables and other kind of vocabularies are key. And about reusability, or to increase reusability, we need licenses for data, these kind of contracts that are somehow implemented in practice using something called connectors, and provenance tracking of the data lineage. I'd like to say that what we are now doing differently is extending this idea of spatial data infrastructure, European spatial infrastructure, so-called inspired, to include many other sources of information like citizen science, Internet of the Things, as well as remote sensing and data modeling. And we are doing that by adding semantics and defining dimensions, and depending on the data model, you get something that's kind of a cubical, what we call the data cube, where we organize data in dimensions, or you get something more object-based, where we organize things into features and their relations. And both two worlds are related because they use the same concepts, they measure the same variables. So this idea of having vocabularies for essential variables and units of measure is really critical in here. And there is some kind of a need of being able, in this big data world, being able of extracting subsets of data, we can call it collection if you want, using different technologies like SparkQL or XArray queries. Forgot to tell you that we still believe in metadata, so this metadata should be also, carried through the processes, and the final structure should have some kind of a reference or a copy of those data. And as I said, there is an open access aspect of it, but it could also be used, the same approach could also be used using contracts for a more controlled use of the data. Okay, so there is one thing that we share with the digital twins. Both concepts come from actually the industry. Now, in digital twins, probably from aviation, things like that. In here, the idea is that we have this International Data Space Association that establish how you can share immutable assets between two machines in a secure channel. So you have a data repository or data repositories that are connected with something that they call a connector. And then in order to get the data, you need to sign some kind of a contract that should be an IT contract. So something that a system can read, not only a human. And there is then the possibility to get that data in that environment. This becomes something different from open data. It's called equally data sharing, but it's kind of a pipe data sharing. The connectors, these kind of a mysterious boxes, they do many things. They provide API access to the data. They provide authentication. They provide content validation. They provide access control. They provide system monitoring and logging. So sorry for too many text. This is kind of a reflection that I'm coming up recently. In this definition, there is an assumption that there was no previous infrastructure to share assets. So that's not the case in the Green Deal data space, because since we are inheriting the Inspire legacy, we have been doing this for 20 years. So actually, what we should do is try to add something to the existing decentralized infrastructure that we have. And in order to think about a Green Deal data space connector, we should immediately remove this idea of a new API for accessing the data. We already have those. We have been doing that for a while. The rest of the things are still valid if you really want to use this data space concept for the digital economy. The whole idea is to be able to implement a predefined contract validation tool that will take into consideration the idea of layer, modernly called collection, the possibility to do geofencing to actually access just an area of the data, the possibilities to understand web service parameters and API filtering capabilities, and the possibility to actually take advantage of the vocabularies that define the attributes and the different parameters that the geospatial data has. In the future, it could be useful also to have data-centric security. That means data encryption and integrity that allows, once the data has abandoned the producer, there is still some kind of a sovereignty guaranteed by the encryption process. A connector, actually, in this view, is just an OGC service that has additional building blocks for security and integrity, or maybe a facade that provides the same functionality in front of the actual service. So from my point of view, the secure-to-enable OGC APIs are actually the Green Deal data space connectors. And they add this idea of collection, bounding box, CQL filtering, and all this stuff that the other data spaces implemented, the other connectors implemented so far doesn't provide. So they are not useful for most of the information on the Green Deal data space that are mainly geospatial. So this is what I wanted to tell you today. Yeah, we will have also demonstrations and pilots. We have some nice diagrams about which and pipelines of the three pilots, but I hope that we can be more specific. We are now at the equator of our project, so still some things to do before we can tell you in full the details of what happened here in the pilot one in Berlin. Can you believe that there are more than 400 lakes there, and they are struggling to actually understand the water quality of all of them, combining different data sources? That's possible for preserving the recreational and reservoir capacity. In the pilot 2, there is this connectivity and these problems of connectivity that is decreasing in the Barcelona area, for instance, around 20% in the last 10 years. And in the pilot 3, we have this atmospheric data that comes from Copernicus services that is actually a little bit coarse, and using and including IoT sensors, the resolution can increase a lot, and then we can see structure in cities, and we can have more informed decisions at the local level. I'm not alone working on data spaces, fortunately, and that's why we want to know about what others think in terms of releasing scientific publications about that in this special issue that we are guesting, if that's a verb. And this is the consortium. So fortunately, we are not doing this alone. We have a brilliant consortium that is working towards that direction. And, you know, please subscribe to our newsletter and all these other things that I have to say for communicating. Thank you.
Thank you. Thank you so much, Joan. Appreciate all this information, and the slides will of course be made available online after you submit it to us, and we will share it as PDF. I asked a question while you were also speaking, and very quickly, I see time is running super fast, and we are still waiting for Mark, but we asked if the audience is planning to use the Green Deal data space. And you see that there's a substantial amount of people, 36% will, 36 not sure, and some are not planning to use it. So it's just, we are a mix in this audience. Okay, Mark, last but not least, we are going to hear about the GREAT project, also about data spaces. And so Mark is working for the EGI Foundation. He's a senior advisor and is guiding the EGI's alignment with the initiatives of the European Commission and with the broader cloud computing industry in Europe, and also with a global open science efforts. So Mark, the floor is yours.
Do I have the right screen showing?
Yes, you did.
Oh, that was the part of today. So thank you, everybody. We've heard an awful lot of information, so I'm going to move quickly through my material and not dwell on too much there. Hopefully we can move along. So a quick introduction to our project. The GREAT project is a coordination and support action, the preparatory action for the actual deployment of a Green Deal data space, which a call for which is expected to be published online any day now. And this will actually translate our theory into practice. So what we're doing in the GREAT project is putting together an implementation roadmap, a governance structure, a technology blueprint, building a community of practice, and identifying some of the high priority data sets. That's not the same as high value. That's high priority in terms of meeting the Green Deal policy objectives. There are many. We selected 3 in our project to focus on: biodiversity, zero pollution, and climate change adaptation, because we were only given 18 months to work and $4 to work with. So we didn't have that much time or resources. So we needed to focus, but we think these are representative. Overview of the project. Yeah, again, there are a lot of, this is more about Green Deal data space per se. These are our project partners working together. I'm from EGI in particular. As many people have said, there are quite a number of data spaces being considered and developed. Some of them are at the deployment stage. Some of them are still moving into that stage. And the idea is to bring the data together to connect fragmented data from different ecosystems. So we'll talk more about how to do that. Oh, okay, so let me just see if I can convince my... There we go. So what is a data space? We've seen a couple of definitions. This is the one I think that's the most recent from the Data Spaces Support Center, which is a distributed system that is defined by a governance framework, which enables secure and trustworthy data transactions between participants of the data space, supporting trust and data sovereignty. It's implemented by one or more infrastructures, and it even enables one or more use cases. So there's more than just a single digital infrastructure involved. It's not just data transfer, it's also terms and conditions. We've heard some of these points already. And from a governance standpoint, the key characteristics of the data space include its purpose, objectives, the rules for membership, standard terms and conditions for data transactions, etc. So just reflecting a bit on the presentation that Arne made at the very beginning, which is talking about data spaces in comparison with the data mesh. I think we can say that data spaces are even more than a data mesh. So for the data product, we do agree it's a data set plus mechanisms to manage, deliver, maintain the data set, including potentially the code and the infrastructure. For domain data, it's owned by the domain owners. There need to be clear roles, and we propose some additional ones: data producers, data product providers, data licensors. Some of these this community is already thinking about. We can explore this or discuss it in our discussion. There need to be service level agreements. This is required by the data mesh, but this is very important for data spaces. So availability today, availability in the future, how long will the data be around? Documented quality levels. This is a complex topic. It's not just a bronze, silver, and gold. There are an awful lot of dimensions to this, which could take up an entire webinar on its own. Responsible for interoperability. So we need to have transparently declared, verifiable standards. We should use common standards if possible. There was an ISO document out on this in this domain, a geospatial domain that we think is a good starting point. But the key point is having those declared and verifiable as opposed to necessarily prescribing something in particular. Transparent declaration of access and use policies. And these need to be machine actionable. This is something that I'm glad to see that the boxes that Joan mentioned in his building blocks. There are also some Legos in simple, but work needs to be done to flesh out what's inside each of those Lego building blocks and each of those blocks from Joan. So I look forward to chatting about that. This is key. Different distributions of data, a data set, depending on the requirements of the user and the access and use levels. If you have two different people asking for data about sea level depths, sea depths, ocean depths in the Swedish archipelago, you're going to get different answers depending on whether you're a defense organization or the average sailor, because they have different rights, and some of these are sensitive data. Self-serve access, catalogs, connectors, and agents, not just the connectors that Joan has mentioned, but we've got agents from simple being thrown into the mix. Tracking of data exchange and transactions. This is very important. APIs alone are not enough unless they are wrapped and enhanced somehow. Federated governments, much more than a data mesh. We need to drive the governance down to the data product. Some of our prior presenters have mentioned this. Right down to the data distribution level. There should be standard agreements as well as metadata for access and use. And then verifiable credentials for both producers and providers on, for example, on quality, as well as on consumers. This is not just a requirement on the production side, it's also a requirement on consumers. So if you have data that is covered by the GDPR or that requires cybersecure facilities, and there's a lot of stuff that's not personal data that does require legally cybersecure facilities, the consumer of that data has to be validated to be concerned to make sure that they have the right kind of recipient infrastructure. Oh dear, I hate this. Okay, so let me illustrate some of this. This is all about attributes. So, and I just can't seem to get rid of this thing. Here's an example of the importance of data attributes. So what's the answer to this arithmetic question? Is it answer 1 or is answer 2? Well, in fact, it's answer 2 because we have to keep track of significant digits and precision. This is an example of a critical extra data attribute that scientists are well aware of. Now we're creating dozens more of these attributes for any given piece of data that we need to keep track of in order to properly manipulate that data. We cannot ignore them. Sorry, every time there we go. So just a couple of reflections on some pictures that I've seen flow past. So this is a screenshot from one of Arne's pictures, a blow up of the connection between the Green Deal data space and the big data lake that was in the middle. I think it was in the context of Destination Earth, but it could be quite general. I'm worried about that dotted line between the two entities. How will data product attributes from each data space be maintained when data moves into the data lake? How do we make this happen? And conversely, if we take data output or generated by the data lake or produced in the data lake, and then move it into a data space, how do we add the attributes when it actually comes from the data lake and goes to the data space? This is something that we need tools for. Another example, another picture, this is the Iliad, and we see Copernicus data space, EOSC data space, and the Green Deal data space, and then up in the upper right corner, and a lovely and multi-talented API that's going to move data from these sources into the digital twins. And again, I have exactly the same question. How are we going to keep track of these attributes when the data starts swirling around inside the digital twin? What are the mechanisms for this? Will the API be able to handle it? And in fact, will all the boxes that are in the Iliad Digital Twin processing architectural framework, how will they handle these attributes? Where will they be? Are they an add-on, or are they intrinsically part of the data item, the item of data that's being worked on? And as a parenthetical note, I know full well that EOSC, as an example, doesn't have a way of managing this information either, even though it is increasingly being talked about as a data space. So that's a problem for EOSC to solve as well. Very quickly, Destination Earth. This is not from Thomas's presentation, but I have seen this in the connection with this. You see all this circle of data: users data, satellite data, citizen science data, other data sources, sensor data, IoT data. How will the data product attributes of all these data be maintained in Destination Earth? Now, I saw an interesting point there in terms of Destination Earth being built on the simple middleware, which supposedly will have tools for this, but I am curious how this will feed into the Destination Earth architecture, and how those specific attributes will be maintained through these very complicated processing steps of the digital twins they're creating. So how might we solve these problems? So I'm drawing some pictures that might be options, and Joan and I can probably spend an hour on these alone, but for the rest of you, you can imagine, so first we have this broader ecosystem, including a variety of infrastructures. So let's say infrastructure X, that could be Iliad, let's say. They might onboard an agent, some particular piece of technology into the Green Deal data space, actually register it as a part of the Green Deal data space, and its job would be to represent infrastructure X and all of the lovely things that are being created within infrastructure X in terms of providing the users of the Green Deal data space with access and visibility to all of those outputs and all of those results, and potentially even those running services, the ability to spin up jobs on the infrastructure that's in infrastructure X. So this is the one on the far left. If you go to the far right, you have a different version. This is one where instead of trying to onboard or participate directly into the Green Deal data space or a data space, there will be some point inside infrastructure Y that's responsible for handling the API calls into infrastructure Y and responding to that. So we would enhance the Access API to manage compliance and to manage the attributes that are going along with that. And as a last possibility, we might be able to bring in service providers who can step in and act as an agent for infrastructure Y, who would mediate between the request from the Green Deal data space and the actual infrastructure to take responsibility for compliance and for providing the right kind of attributes. So those are a couple of possibilities. I don't think they're exhaustive, but a few possibilities. And I know that CREAF and AD for GD are in fact testing some of these. So as a last point, which I think is very important, for this Green Deal data space to be really useful, I think we need to promote circularity. And the data product concepts that we've already talked about already provide a foundation. They have the transparent declaration of access and use policies, which should cover the reuse possibilities and a mechanism for handling that. They have documented quality levels, which assist in this process. They're already tracking data exchange and transactions, and so there's a direct support for this lineage or provenance capability. But we think a few pieces might additionally be needed. So linking quality to verification services, either from some trusted verifier or provider, or through a social mechanism such as a peer review, mechanisms for storage and potentially analytics inside the data space. And if I can move this box, and then trusted report submission services if there's a reporting requirement under regulation. So here's I guess a forward look into how we might have to deal with what we might need to do in the Green Deal data space to support circularity. And once again, there we go. And now I'm done.